Hi guys. Now we are going to see one more problem of conversion of NFA to DFA. So this is our question given. Construct DFA equivalent to the NFA. The definition for NFA is given to us. As we already know, a finite automata is defined by 5 tuples. So these are the 5 tuples that they have given. So this is Q, the four states. This is the input character sigma. This is delta, the transition function. P, which is the initial state. Q and S, these are the final states. So Q and S are my final states. My initial state is P. Okay, and delta is also given to us. Delta is the transition table. The transition table is given to us. So now using this NFA transition table, I'm going to construct the DFA transition table using our direct method. So what do? We first take the initial state of NFA, that is the first row. So for DFA, P for both the input characters 0 and 1. So for P we have Q comma S and Q. So the first state is done. This is the initial state of DFA. Now what should I do? I should take the next new state that is existing here. So P is the 1D state I know. The next state is Q. Yes, this is a new state. So I'm going to take Q comma S. This is my new state. So how do I find the transitions for 0 and 1 for QS? Again, we go to the NFA table for Q and S. So for Q and S, for 0 transition, what do I get? Unioning Q and S for 0 transition. So it is R and phi. Phi is empty set. So R and phi, unioning R and phi, what do I get? I get R. So it is R here. And again, Q and S for 1. Q and S for 1, it is Q, R, P. So P, Q and R. Combining both these, we get. Again, so Q, S is done. Now again, I have another new state Q. So Q. For Q, already I have the transition. So for 0 transition, it is R, and for transition 1, it is Q comma R. So this is done. Now coming to the next row. So R, is this a new state? Yes, it is a new state because these are the 1D states of DFA that I have identified. So now R also comes in. R. So for R, the transitions are, for 0 it is yes, and for 1 it is P. So I will have yes and P. So R is done. Then PQR. Yes, this is a new state. I don't have PQR here. So again, I take PQR. So PQR, how do I find 0 transition? P, Q and R, combining all these 3. So what do I have? Q, R and yes. So Q, R, yes. Again, for 1 transition, PQR gives me P, Q and R. P, Q and R. Done. So this transition is done. Then in this row, R is already there. QR, it is not there. So QR is again a new state. So I'm going to take Q comma R. So Q and R for 0 transition, it gives me R and R comma yes. And Q and R for 1 transition, it gives me PQR. PQR. So QR is over. Then coming to the next one. Yes. Do I have S here? No, I don't have yes. So we take yes as a new state. For yes, what is the transition? It is phi and P. Again, P is already there. QRS. So QRS, I don't have QRS. So I'm going to take QRS as a new state. So QRS. Combining QR and S for 0 transition, I get R comma yes. And for 1 transition, I get P. So QRS is over. PQR is already there. R, yes. We don't have RS. So that is the next new state. So R comma yes. So for R, yes. R, yes. For 0 transition, it is just yes. For 1 transition, I have P, just P. So RS is over. PQR, I already have that state. Yes. P, it is already there. RS, it is already there. P is already there. Yes is already there. P is already there. So we don't find any new states. Now our DFA is done. So what is my initial state? P is my initial state. How do I find my final state? See here, Q and Q and S are my final states of NFA. So any state containing Q or S becomes my final state in DFA. QS, this will be my final state. Q, final state. Q, final state. Q, final state. Yes, final state. QS, final state. Yes, final state. So I have these many number of final states.